Hello guys, and welcome to 2021. So we just started the sessions Gigster Thursday. Yeah, just like last year, this year it will be big and great and full of learning opportunities, sharing, building communities, open source projects, and etc. So yeah, if you can just see the picture there, the background there is Eldoret, where the whole story began. So Gigster Thursday is a community for devs to learn, engage, and share knowledge. And the slogan is "Let the commit speak," and is brought to you with love from AppsLab KE. So what we do every Thursdays, so we do introduction to development. We always have series of hot labs, fireside chats. We talk about productivity, teamwork, and collaboration. Also, we do about product review and launching. If you are working on a product or have any that we can discuss about, we can schedule such sessions. Then we also do open source. So other interesting activities to check out these YouTube channels. For every sessions we do, we always record and upload these to Gigster Thursday. You can check it out on YouTube. Otherwise, you can also check. There's Frank Tamre, there's Tech Detailed, and also if you know of any other local or some YouTube channels that we can include in this list, you can share with us so that we can add it here. Yeah, if you're doing one or you know of any. So there's Android 254, Kotlin Kenya, Flutter Kenya, and Atlassian community. These events are back. For Atlassian community, they are on site at iHub. You can go to Telegram and search for AC Nairobi, AC Nairobi or Atlassian community Nairobi, and check out. So like they have a meetup this weekend on Friday or on Saturday, I mean, from 4 p.m. There's 100-254. Go to Meetup, look for 100-254. They also have an event this Saturday. There's also, you can also check them on Telegram. This is the biggest Android community in Africa. So same to Kotlin Kenya and Kotlin Kisumu. The events are back. Also,
Unajua msa amechukua like 4 days ago tena.
we have like the MongoDB community is also a new one. I didn't add it here. So they are having their first meetup this Saturday at I have from 1 p.m. So you can also go to Telegram and search for MongoDB community Nairobi and look out for their next events. So there is DroidCon. This is the largest Android developer conference in Africa. So last year it didn't happen because of the pandemic. So this year is going to open back and bigger. So you can go to .con.co.ke and check out. You can go to Twitter at .con.ke and follow for more updates. Yeah, so you can find Gigstock Thursday activities on YouTube. Gigstock Thursday is the channel, or for the open source communities contributions, you can go to GitHub and look for the organization Gigstock. So today, very happy to have Cyril Tumbo, who is a lead backend developer at Catch Taxi. Yeah, so there's one thing I've noticed with Cyril is that every year when we start the sessions, he's always the first. Now this is the third year in a row. He's always the first to present every year. After that, evaluations that gets lost. So I hope this year he will be staying for more sessions for us. So I'm moderator of today. I'm Magak Emmanuel. I'm a software developer. So all this is brought to you by AppsLab. So what we're going to discuss about today is GRPC for optimal microservice communication. So just invite you all to stay back and learn also and share. If you have any questions, we'll be having a question, a Q&A at the end. So at this point, I think over to you, Cyril, so that you can proceed. Aaron, you can just only make him a host. I'm not sure if he is one.
Yeah. Good evening. I don't know if my English is sufficient enough, but we'll go with that.
We'll
Oh, you guys, can
survive.
you hear me?
Yeah.
Okay. Harun, am I a co-host now?
In a few.
Okay. Yeah. So for those who are
Yes, you should.
poking into my grammar, be warned. My English is not sufficient. So okay, kidding anyway. Hope you can see my screen. So yeah, as it happened, Magak has very nice screens compared to mine. So that's what backend developers do. We just focus on words, not on beauty. Anyway, so I'll give you maybe a brief history of why I use GRPC and why I chose it for this topic. Initially in 2019 November, I was tasked to build a taxi application software, and the existing software was a monolith. They were planning to scale into catch taxi application. Catch taxi company operates in two countries, that is Kenya and Ethiopia. So the initial application had issues in such way that if we had like 600 online drivers, okay, mostly a taxi application relies on streaming location updates. So the initial application had issues with streaming locations to the server. So if at times when we had like 600 drivers online, it could throttle the server. And so at that time, the quick fix that we used to do was to go to the server, use sudo reboot. So it used to be like that. And then when I came to the company, I was tasked with the work of creating a fully fledged system. So the first 3 months was doing a bit of research. The initial plan was we wanted to use we were looking for a protocol in which would offer us performance, offer us security, and also reduce network congestions. So we thought of going the REST way, and so the first microservices like 2-3 were based on REST. After doing REST microservices, we did a stress test. So after doing a stress test, we realized there were performance issues that we encountered. REST was not like it. I mean, if we had like let's say 1,000 concurrent connection, REST was being overburdened. And so it forced us, we went to docs, Uber docs, we read Uber story, read what they did. We realized they had moved from that model of using REST to other technologies. So we resorted, we said, let's try to do sockets. So we did sockets. And again, we were faced with an issue of bandwidth because socket opens an entire connection throughout the day. So now the question was, the company needs a product ready in 6 months, and we don't have an optimal way of doing microservice communication. So we resorted to use a communication protocol, an RPC communication protocol based on RabbitMQ. So I hope you guys know what RabbitMQ is. So we also did that. We subjected it to couple of stress testing, performance testing, and it had its shortcoming. And so after doing some Googling and all that, we came across a GRPC thingy, GRPC thingy. So at that time when it was in its preview, but we decided to try it out in preview. So we took GRPC, did configuration and all that, and then we subjected it to the same metrics that we had subjected the previous technologies. And what amazed us was GRPC was surpassing other technologies in all those metrics. Excuse me. And so now these became our optimal tools for choice. Because, okay, the company, we were working with a budget in mind. And so the company had its budget and also had its performance requirements. If we were rich enough, we could have afforded like a socket connection, because we could have been able to buy all resources that we need, been able to spin multiple clusters the way we want. But now, since we had like a budget issue, we had to use GRPC. So GRPC, we did build GRPC. At that time, it was experimental. So there were no docs at that time. So we were just learning things as they go. You find a bug, you struggle on it, and you fix it up. And so the entire architecture was based on gRPC. Up to now, the system is working on gRPC. So as I'm presenting to you, I'm presenting something that has been tested, and it's working. So so let's get right into it. Let me hope I've not bored you with a long story. I usually didn't think myself as a storyteller, but it so happens that I am. Okay. gRPC for optimal microservice communication. So, what's happening with my, okay. So, if you need written via email, that is me, lead backend engineer, Catch Taxi. So what are we going to do today? So we're going to look at what is gRPC and why would I want to use it, or would you want to use it? On the second one, how would I use gRPC today? What are the strengths and weaknesses? So we are going to basically focus on those two main agendas. Okay, so currently, like, everyone is going to cloud, and as people are going to cloud, there's a need to do an optimal way of shipping products and optimal communication channel. So you won't get these problems if your focus is on a small scale project, like a project for logging in and doing what. But if you have a multi-cluster project, a communication protocol between microservices becomes an issue that will interest you. So if you are a newbie, or if you're starting to program, I don't think you'll face these problems as of now, but in the course of your development, if your role is to become a senior or a full stack developer, you'll need to understand the complexities that are involved during deployment, and how to optimize your communication channel via microservices. So basically, this is me doing a sketchy drawing, so don't mind about my weird, sketchy, whatever. But basically, the idea is we need to make sure we have a seamless communication between these services. What is gRPC and why would I want to use it? Okay, gRPC is an RPC struct developed and used by Google. It was open sourced in February 2015. So it's been here on the market. It's platform independent. So what that means is it does not care which language you use, whether you use Java, whether you use Python, whether you use the PHP, whether you use Rust or what. Yeah, those funny languages. whether you use Kotlin, like it's platform independent. So you don't need to care. You only need to, as in you only need to create a service and you don't care who consumes it. So it is high performance. It's based on protocol buffers. So protocol buffers, that is what we call Protobuf, and HTTP2. If it will take some time maybe to go and research on HTTP2. So HTTP2 basically enables streaming. It also is secure. It's faster. Like basically, it has the best you could wish for. HTTP2. So if you've used it, you'll understand its advantage. But maybe you can go and check it out. So it's necessary to external services that are GRPC. It's a good choice for your own system if you want efficiency, robustness, well-designed, implemented, tested, and cross-platform RPC. So usually GRPC is used with Protobuf. So to understand GRPC, we first need to understand Protobuf. So what is protocol buffers and why would I want to use it? Okay, so protocol buffers basically those it's somehow like it's a protocol buffer is basically like a contract between you and the client. So it has various rules that you need to, as in that the client and the server need to engage in. It's based on binary serialization. So basically, unlike JSON, okay, JSON is text-based, but protocol buffers are binary. So meaning, when you compare the size of a JSON file and the size of a binary file, as in the size of a protobuf file, during communication, you realize JSON file as in is if you're transferring data over a network, the size will be larger than compared to an RPC binary file. So binary serialization in RPC enables that information is transferred in zeros and ones. Okay. So and also if you look at protocol buffers, the way they are architectured, basically as in they have been made simple. They have made simple. They have okay, if you've tried to work on YAMLs, you realize that protocol buffers, they have they have like intelligence tools. There is autocomplete. So basically, working around them is easier. Okay. 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 So without much further ado, let's head back to a demo. So I'll start by showing you what a protobuf looks like. So I've done two projects. One is a gRPC client, another one is gRPC server. For those guys who hate C-like languages, please bear with me. But don't worry about the language. Just focus on the concept itself. Focus on the protocol. So a protobuf usually looks something like this. Shows something like this. So the syntax indicates the protobuf version. So basically, this protobuf is proto version 3. The import is when you need to import libraries. So basically there are libraries that have been open source out there. So if you want to do some things on protobuf, you can just import them. The option, this one is maybe if you want someone who does C#, if you want a C# specific thing, you can do there an option. If you want Python specific thing, you can put under option. If you want a Java specific thing, you can put there. So we have there's a package. It's a package. Then there's a service. So a service is like a class. Service is a class. Then under services there are methods. So like, so you say this is an RPC method. Okay. There's chat somewhere. Hmm. Oh, you guys
Cyril, are
cannot
you
see
sharing
anything.
Yeah, we can.
Oh.
We are on demo part.
Oh, sorry guys. Sorry. No, the bad thing of being used to what? Being used to Skype is this thing has post sharing, new share. Okay. Sorry about that. I'm used to Skype. It usually gives me whatever. You can use it now an ID.
Yes, we can.
Oh, sorry for those guys who are wondering what. Yeah. So, okay. Now let me start from scratch. This is the structure for Protobuf. So there's syntax. Syntax indicates the version of the Protobuf. So this Protobuf is version 3. And then we have an import. Import basically if you want to import libraries. And options. The option indicates if you want language specific as in things, like if you want things that are specific to C#, things that are specific to Python, things that are specific to Java, you can put under option. Then there's package, and now we have a service. So a service, like I said, a service is like a class. So a service is a class, and then under the service we have methods. So like here we have two methods, say hello and login. So say hello takes in hello request and returns a stream of data. Login takes in hello request and returns to hello reply. So what does this hello request look like? So hello request is like in Java is like a pojo. In I don't know what other languages have. Yeah. In Kotlin, I don't know what is Kotlin. Is it data objects or something of the sort in Kotlin? Anyway, so this is like a pojo. So this hello request has in Protobuf, if you have to, every parameter you have to number it. So you start from 1 going downwards. So like string name 1, string password. So you also have another pojo or another whatever, another like an RPC object. So we have like string, this one has one parameter, and then we have weather data. So that is the overall, like a basic structure of how a protobuf looks like. So so basically, like in RPC say hello, I'm saying that take in a hello request and return a stream of weather data. So I will start with doing you a demo, as in not doing you English. I'll start with showing you the capabilities of GRPC. So let's say, for instance, you have something like I'll give you the taxi example. Let's say you want to stream data to like driver location to passenger devices. So GRPC can enable you to do that. So you can be able to stream like a driver's location from where he's moving. If you guys have ever seen Uber, when you go to Uber and you usually see like driver, as in the driver cars are moving. So that's an example of streaming. Or if you've ever watched Netflix, you wonder how those guys do it. So it's an example of streaming. Okay. So I'll give you I want us to see how streaming operates. So let me hope I don't forget this time to share the screen. You share. How do I share to screen? How do I share? Oh, you can share multiple. Oh, interesting. Can you guys see multiple terminals?
Yes.
There's one with something here with GRPC server.
And
There's one that ends GRPC client. So I'll start
yes.
with running a command. Don't worry about this. This one is for haters. It's the way serious people run systems. Anyway, so our server is up and running, and now I want us to stream like data from the server to the client. So so 1, 2, 3. Come on. So okay, can you see what is happening on the terminals? Hello.
Yes, yes, yes.
Yeah, so basically I'm sending data from the server to the client. So I'm streaming like this, as in I'm streaming data from the server to the client. So okay, so the stream is complete. So let me explain what just happened. What just happened? New share. Oh, this thing is killing me. So GRPC server, GRPC something, GRPC what? So okay. So what is happening here is I'm sending data at an interval of 500 milliseconds. Let me see how many. 500 milliseconds. I'm sending data at an interval of 500 milliseconds to the client. So once the what the client does, the client just opens a stream. He says, I want to stream data here. He says, I want to stream data. So once he says, I want to stream data, so the server starts sending messages, random message. It's just a random pojo here. So he sends messages at an interval of 500 seconds, at least so that we look busy, that something is happening. So it sends messages after an interval of 500 milliseconds. So basically, you cannot achieve this in REST because REST is unidirectional, but gRPC is bidirectional. What that means is the server can send a message to the client, and the client can send a message to the server. So I want us to do. I want us to maybe just show you something how it's easier with gRPC. So with gRPC, you don't need to write code for implementation. Not code for, as in you don't need to write code for integration. So you realize with the API, you have to consume the API, right? You guys don't consume APIs. With APIs, you have to consume the APIs. But with gRPC, you don't consume anything. What you just need to do, let's say, for instance, let's add, hope you can see my screen. Can you guys see my screen?
Yes.
Yeah.
Okay, so let's do a method. Let me show you what I mean by when I say you don't need to consume anything. So let's say test method. So it takes in hello request and returns hello reply. So takes in, okay, people can say maybe I have had coded this hello request. So let's say, for instance, we want this hello request to contain a string of, let's say, input. Then let's give it an index of 1. So once we've done that, so it's hello request. So with gRPC, once you've done that, you don't need to write any other code. What you just, somebody will share a protobuf, this protobuf to you. The guy who has done the server project will share a protobuf with you. So the entire integration, the only thing you need to do, whether you are using Kotlin, whether you are using Java or whatever, you only need to, for Kotlin or C# or Java, you only need to build the project. So you only need to build the project. So once I have built the project, so you only need to build the project. So, okay, let me hope that is ready. So once I've built the project, you realize you will have another method. So you've seen the only thing I've done. The only thing I've done, I've added this one only, right? That's the only thing I've done. But now, once I share with you the Protobuf, once you rebuild the project, the GRPC will consume the API and give you the RPC method. So the only thing I come here and say, I'll just come here and say override test method request. So you see that test method has already been implemented by GRPC. It has, as in the consumption part has already been done. So what I only need to do is I need to tell it that if somebody calls this method, what does it need to be done? I don't need to worry about how it's consumed or how it calls what, how it does what. I don't need to worry about that. The only thing I need to worry about is if somebody calls this method, what does it do? So let's say, for instance, if we call this method, let us return. Let us return of case. This is C-like languages are usually new hello reply. New hello reply. Hello reply. So I'll just say here message. Yay. We call here. Yeah, so public override async. So don't worry about those as C# things. Yeah, so once I've done that, so the only thing I'll do now, since I've changed the protobuf on the client, I'll share the file as in on the server, I'll share the file to the client. So what the client will need to do will I'll give him a file that is updated. So this is the client, this is the client, this is the server. So I've copied what I've changed on the server. I'm now pushing it to the client. So I'll push to the client. And what the client will need to do will just come here and build the project. Just come here and build the project. Whether you are using whatever, is still the same. Oh, so I only need PC. Okay, I need this namespace because I need it here. So this is C# specific code. Here, PC. Don't worry about that. That's in C# option. So if you have, okay. So once I've done that, okay, let's stop streaming. Let's stop all this. I'll just say await client dot, okay, let's var result await client dot. You see there's test method already, and there's an async one already implemented for me. So if I do this hello request, then I pass something here, input test. So what do you need? Test. Okay. Okay, so what is the error? Oh. So new Okay. Input test. So let me hope I'm not boring you. So I think, okay, the point I'm trying to say is the implementation, the consumption part, you don't need to worry about. You just need to receive the protobuf, you build the project, it will create the consumption part for you. So what you need to do is just call the method. So if we do that, we should be able to receive something like this. Yay, we called here. So let's try to run it. So new share here and here. Oh, new share here and here. So and here. Okay, let's run the server. Oh, I've not printed the message, so let me see. So that is result. So console.writeline. For those who do Java, that is message. That is system.out.println. So can you guys see the screen? You can see some console messages somewhere. Okay, so if I run, okay, I've changed it to output on the code, change it to output. So if I run here, it should say yay something. .NET run. So you can see there's yay we called here. So okay, where is Visual Studio? Okay, so the point I'm trying to say is this test method, I did not need to write it on the code. So if I go there to go to definition, you'll see like this whole class has been generated for me. Can you guys see it? Or can you see some weird codes here written? Hello?
Yeah.
So you can see this, like the entire, all of this thing. I did not need to write it, but it's already here. It has already been. The only thing I need to, the only thing I had to do was to add this method. Once that one was done, these other things, these are the consumption, everything were done for me, generated for me. So if you have a Kotlin client, it will write a Kotlin code for you for consumption. If you have a Java client, it will write the Java client for you. If you have a Python client, it will write the Python client for you. So the only thing you need to know of is there's usually a method that you need to call. So that is the beauty of GRPC. Like there are things you do not need to do. Like with REST you have to write, you have to have the swagger, write the implementation. But with GRPC, you don't need to do that. You only need to know that you only need to know two things. You only need to know there's a protobuf. So once you have that protobuf, you just build the project. Once you build the project, it will generate the client code for you. So the only thing you need to pass is an address. There's an address, a URL indicating where this microservice is. So so that is maybe pretty much it about the demo. Unless maybe someone has a question on the demo, or there's something that needs to be clarified before maybe I wrap it up.
I have a question.
Okay.
So, did you maybe explain on the server setup, or maybe how do you set up, like generally, like the gRPC on the server or something of the sort?
Okay, so let's do something crazy. Let's do something. Oh, just a minute. I'm opening up. I've closed the window, and so therefore Zoom has tried to tell me share screen. So Visual Studio. Can you guys see something like Visual Studio?
Yes.
Aaron? Okay, so with C#, this is what you do. So there's a way you can set up a project for PHP, Python. So there are packages for that, but with C#, there's usually there's a template for that. Just need, let's say, GRPC, my server. With Laravel, there's a ways you have to do that. With Python, there's also ways you have to do that. With Java, there's ways to create a gRPC project. Or alternatively, you only just need to add, oh, what this thing is playing hide and seek with me. So they are like you only need to know of there are these packages or packages like for C#, there's a.NET Core package for gRPC. So once you create a project for that, you like for C# will be given like files, grid, or with services. You can also add your own protobuf, like add new item. So let me search protobuf. So protobuf, let's say Gigster. So you'll have that, then you'll have you'll write package. So package, let's say gigs. Okay, then you'll get a service. Service is like live service. Gigstock. Then you'll create not methods. You'll create like you'll create the Pojo. Let me use Pojo. So string message. So string message. Now let's say, for instance, how to write a method. We'll just say RPC. Let's say method name called test. Then it takes in hello, and it returns hello. So to avoid it giving me issues with reference, I'll copy this here and do that. So once you've done that with C#, you'll only need to reference that protobuf here. So I'll come here and reference it. Tell it I need something here. So it is Gigstock. So once you've done that, you'll build the project the usual way. Just build the project. So once you've built the project, you'll create a service. Add class. Like now where there's implementation, like where you now, after consuming the APIs, where you now like indicate what these things do. So Gigstock, public geek, let me see, public Gigstock dot okay Gigstock. There's there. It has already generated for me the code .gigstock base. So you'll do that. Then you say Gigstock. Then you can write public over public. Okay, you can literally inherit the methods of this class by doing something like that. Then public override. So if you once you've inherited that, it will give you an access to all the methods. So like for instance, in our Protobuf, we created a test method. So if you come here, like if you just automatically, the method hello has been created for you. Is that method. So now you implement it here. So also on the client, like you've seen there, it will just happen like that. So on C#, it's just as basic as that. That's all you need to do. So as in, okay, the essence of GRPC was to make sure that they abstract complexities from you. So you only need to know, you only need to worry about what that service does more than how to communicate between services. The communication part has already been abstracted for you. So the implementation, like consumption or whatever that has already been implemented for, has already been implemented for you. So you only need to know about how to, what that method does. So basically, once I have done maybe that, I've told this method that do this, I'll now share this Gigster.proto to an Android client or a web client or to a microservice. So to a microservice, for the microservice to communicate with my microservice. So basically that microservice will now under the hood be a client to this a microservice. So once that client opens up a communication with this, then we can have a bidirectional flow of information between this service and the other service. Any other question? Or Harun, are you satisfied, or was I just talking to with
You have
myself?
answered me.
Okay. Any other question?
How many concurrent requests can it handle, like let's say per minute, per second or so?
Okay. In my experience, I don't think there's a limit. A limit maybe depends with your resources. I don't think there's a limit because I tried a simulation of having 50,000 concurrent connection and it happened. We tried 100,000 concurrent connection. So basically, maybe what might limit your concurrent connection, maybe it's the server IOPS. If you spin up a server, each server usually has the maximum input output per second instruction that it can have. So maybe that can limit you. But now when it's if it's within the server communication, a local communication between the services, I don't think there's a limit. But if it's an outside communication, maybe the server input output per second IOPS can limit how, or as in how that will operate.
All right.
Okay. Any other question, guys? I don't want to seem like I'm talking to myself. Hello? Manu, umelala?
No questions for me. Mimi ndaenda kusoma hii kitu vizuri.
Yeah, so okay, one thing I can tell you, since I went the GRPC way, I haven't regretted ever since. The system that I've run with GRPC, there are around 3 systems. And up to date, we haven't had an issue of microservice communication breakdown. It has always been seamless. So that it's how many, since March last year. So that is around how many months? Yeah, everything has been working perfect. So maybe to wrap up things, where was that thing? To wrap up things. Okay, so basically, we should have seen this. So I didn't have anything. Okay, so GRPC has numerous use cases. Microservice communication This one I'll vouch with it. I can tell you, you'll have a great boost microservice communication. You can also use it if you are tired of using REST. You can also you can give an Android client a Protobuf and they can implement that. So you can use it like in a variety of applications, whether web, that is React, whether mobile application, you'll always have gRPC. And the good news is almost the big servers, as in the big web servers, Apache, Nginx, they support Protobuf communication. So you won't get an issue with connection whether you're using Nginx, Protobuf, IAS, or any other thing that, as in any other web server that is well known. So it will be streamlined. So if you want to learn more about gRPC, you can go to github.com/gRPC/gRPC. If you're a .NET guy, the last two are for you. But if you are a Java, Python, Kotlin, you can use the first link, github.com/gRPC/gRPC. Thank you. Any question is welcomed. Okay, where do
I have maybe a last question.
okay.
You mentioned something to do with, what do we call it? With the WebSockets, you had a kind of a timeout or something of the sort.
Yeah, it was a bandwidth issue.
Yeah.
Yeah.
Was it on the server or because on the sockets or WebSocket side?
Okay. You see, when you open a WebSocket stream, there's a bandwidth that becomes an issue. So if you have unlimited bandwidth, then you can use WebSockets. But if you do not, if you are if your issue is with budget, I wouldn't advise you to use WebSocket. But if your issue is not budget, you can use WebSocket. If you have money, that is, if you are rich enough to afford to pay for bandwidth, I'll advise you to do that. But if not, if you are on budget and you need something fast, you can use gRPC. Okay.
So I think if there's any other question, we'll just stop the recording. So thank you, Cyril, for this, for your time and for doing this session with us. Yeah, and
Thank you.
yeah, so I think I'll stop the recording.